for lesson 4 of our expressions unit, we'll be talking about the properties of operations. And we know some of these already, but we're just going to be a little bit more in depth, and then we'll practice using them to see why these might be useful going forward in our expressions unit. Okay, expressions follow certain rules called properties. Anytime we use a property, it will result in an equivalent expression. So whenever you need to make a change to an expression and you need it to stay equal, you can use these properties. For our first property, we'll be talking about the identity property. This is for addition and for multiplication. So the identity property comes from this word identity, which means to stay the same. So when you use the identity property, you're using the identity. It's the number that makes the expression stay the same. So in adding, if you add 0, nothing changes. If you multiply, you can't multiply by 0 because that would equal 0. But if you multiply by 1, nothing changes. So let's try an example. For this whole page, let's say that whenever we see the letter P, it's going to equal 2. Okay? So fill it in. If P plus 0 is supposed to equal P, if I fill in 2 for P, 2 plus 0 is 2. So it works out. Other example here would be P times 1 equals P. If P is 2, times it by 1, it's supposed to equal 2. 2 times 1 is 2, so it worked out perfectly. Okay, next up, the commutative property. We talk about this one all the time. The commutative property is when you change the order. And when you change the order, it stays equal, or it stays equivalent. It works for adding, and it works when you multiply. So P plus R equals R plus P. All we did was change the order. Same deal for multiplying. P times R is the same as R times P. Let's try filling out with numbers just to get a better idea of what this means. So we said P is always 2. Let's say that R is always 4. Okay? So P plus R equals R plus P. P is 2. R is 4. And it's supposed to be the same as if we fill in over on this side, R plus P. Okay, so check each side. 2 plus 4 is 6. 4 plus 2 is 6. And they are definitely equal. So that one works out as well. Try with multiplying. P times R equals R times P. P is 2. R is 4. Multiply. It's supposed to equal 4 times P, which is 2. Let's check. 2 times 4, that's 8. 4 times 2, that's also 8. Those are definitely equal. So it works out with our example. All right, the next one you've probably heard of. We don't always see it, and it's easy to forget this one. It's called the associative property. The associative property is when you make groups. And if you change those groups, you still have an equivalent expression, as long as you change them with this associative property. And again, it works when you add, and it works when you multiply. So let's try it out and see what it looks like when we're using it. So P plus R grouped together plus S is supposed to equal P plus grouped together R plus S, meaning that we would add the P plus R over here first, the R plus S over here first, but it wouldn't make a difference. Same deal with the multiplication. If we did P times R, then times S, versus P times the group, R times S, where we would have to do R times S first and then times P. It's still supposed to be equal, no matter where we put those grouping symbols. That's what the associative property tells us. So let's try it out. So we've got P plus R grouped plus S equals P plus the group R plus S. So we've got P is 2, R is 4, and then S is 3. P is 2, R is 4, and then S is 3. So we're just filling it in with the variables. P is 2 plus the group, then R is 4, and S is 3. The only difference here is that we do our parentheses first. So on the left side, 2 plus 4 is going to be 6 plus 3 equals. On the other side, 4 plus 3 we have to do first, which is 7, and then it's 2 plus 7. Now if we add both sides, we're going to get 9 on the left, 9 on the right. So it worked out, 9 equals 9. So either way, we added with the P plus R first in the group or the R plus S first in the group. It didn't matter, we got the same answer. The multiplicative version of this is going to be the same thing. So P times R times S equals P times, and then the group R times S. Same variables. So the P is 2, the R is 4, close that parenthesis, and then the S is 3. This should equal P is 2 times the group R times S. And since this property is true, this is going to come out true. So we'll do our parentheses first on both sides to check it. This is going to be 8, then times 3. Over here, we're going to get 12 times 2, 24, 24, and it is indeed equal, exactly how we wanted it to be. Okay? Last one, and this one's kind of the easiest to identify because the name literally tells you what it means. The zero product property. 0 is 0. Product means multiply. So the zero product property means to times by 0. Okay? So anything times 0 equals 0. So P times 0 equals 0. In this case, we know that P is 2. So 2 times 0 is supposed to be 0. And if we do it, 2 times 0 is 0. So it works out that it equals to 0. So that property, whenever you see multiplication by 0, it's the zero product property. All right, so we're going to actually take these properties and we're going to use them with different expressions that have different variables. But you'll notice here that we're not given the value of any of the variables. So we will not be evaluating like we did in the previous lesson. We will be using the properties. And when we use the properties, we create an equivalent expression. So in this last column, we're going to be writing in an equivalent expression from whatever property it told us to use. So first up, the commutative property of addition. Remember, that means to change the order. So if I have 18 plus, and that's a Q, we're going to get, flip it around, Q plus 18. And those are equal based on the commutative property. The zero product property means times 0, like we talked about earlier. So if we have C times 0, that's going to be 0. Okay, next, the multiplicative identity property is the identity property with multiplication, meaning what makes something stay the same when it's multiplied. And that would be times the number 1. So if we do x times 1, that's just x, because anything times 1 is itself, based on the multiplicative identity property. The commutative property of multiplication is like the first one, except with multiplying. So if we change the order, it won't change the value. So an equivalent expression would be B times A, because B times A is the same as A times B. Next up, the additive identity property. So just like the multiplicative identity property, just easier to say. And when you add, it stays the same when you add 0. If you add 1, it wouldn't work. It wouldn't stay the same. So 19 plus 0 is just 19. And those are equivalent expressions. Zero product property. Again, that means to multiply by 0. 0 times G. So anything times 0 is 0. So this is still 0, even though this is an unknown variable. Commutative property of addition. Remember, that's when you want to change the order with adding. 7 plus 9, change the order, would be the same as 9 plus 7. Multiplicative identity property again. Remember, this is when you multiply by the number that makes it stay the same, and that is times 1. So 1 times 45 is just 45. The associative property of addition is when we deal with the grouping. So we're going to change the order by changing the group. So instead of 5 plus 6 first, now it's going to be 5 plus 6 plus 8 grouped together. So if we were to solve this, we would actually add these two first versus the 5 and the 6 first. But it doesn't matter because the associative property tells us that they're the same. Additive identity property again for this one. Remember, we add 0. Adding 0 changes nothing. It doesn't matter that I don't know what H is. It's still going to stay as H. It could be 100, it could be 2, it doesn't matter. H plus 0 is H. Commutative property of multiplication. One last time. This changes the order. So 13 times 6 is the same as 6 times 13. Okay, so last up. Let's make sure we got it here. So we're going to match which ones are equivalent. So A plus B grouped together plus C would be equivalent to the only other one with groups, A plus the group B plus C. Okay? And we've got A times B times C. And then I see down here at the bottom, if we switch A and B, well, those are still equivalent. A is the same as A times 1. And then finally, C plus B plus A is the same as if you switch that C and that B to get B plus C plus A. Column 1 over here in our last chart, G plus 0. That's just G. E times the group F times G. And I see over here another group, but it's different. Those are still equivalent using the associative property. E plus F plus G. Change the order. You're going to get G plus F plus E. Completely changed the order on that one, and it doesn't matter at all. They're still the same. You can add in any order. Lastly, G times 0. Doesn't matter what G is. It's still going to be 0 if we times by 0, and that's the zero product property.